Hello and welcome to this ninth set of problems on logarithm. In this video, we will solve problem number 81 to 90. So as always, I say that when I'm stating the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. So without further delay, let's get started. By the way, this video I have decided to record on Windows. Earlier videos were on Linux. So you'll see the cursor is of hand from Adobe Acrobat. Earlier it was a pointer. So problem 81 says that solve 5 plus 2 square root of 6 into x square to the power x square minus 3. This should be in power plus 5 minus 2 square root of 6 to the power x square minus 3 is equal to 10. So we see that 5 plus 2 square root of 6 into 5 minus 2 square root of 6 would be 25 minus 24. That is 1. So they are reciprocal of each other. So we can write this as 5 plus 2 square root of 6 to the power x square minus 3 plus 5 plus 2 square root of 6 to the power minus of x square minus 3 is equal to 10. So we let 5 plus 2 square root of 6 to the power x square minus 3 as z, and then the above equation will become z plus 1 by z is equal to 10. So it will form a quadratic equation, that is z square minus 10z plus 1 is equal to 0. The roots of that would be 5 plus minus 2 square root of 6. So now we substitute the value here. So x square minus 3 would be 1 and minus 1. So in that case, x would be plus minus 2 and plus minus square root of 2. Problem 82 says that for x greater than 1, show that 2 log of x with base 10 minus log of 0.01 with base x greater than equal to 4. Uh, so what we do is we write 0.01 as 10 to the power minus 2. So if we take out minus 2, it will become plus log of 10 with base x. Now this we can write as 1 by log of x with base 10. So we have 2 into log of x with base 10 plus 1 by log of x with base 10. We can write what is inside as a square root of log of x with base 10 minus 1 by square root of log of x with base 10 whole square plus 2. Now we know that x minus 1 by x whole square will be greater than equal to 0. So 2 into this uh, term plus 2 will be greater than equal to 4. Problem 83 says that show that log of a with base b plus log of b with base a is greater than 2. So in this case, we let z is equal to log a with base b. Then we can write the expression as z plus 1 by z. Now clearly this log of a with base b, that is z, is not equal to 0, because if that is 0, then 1 by z will become infinity and the problem will be undefined. Now there can be two cases. The first case is when z is greater than 0. When z is greater than 0, this modulus of z plus 1 by z can be written as square root of z minus 1 by square root of z whole square plus 2, which is greater than 2. And if it is less than 0, then z is minus y. In that case, expression E is z plus 1 by z is equal to minus y minus 1 by y. Now this, when taken out of modulus, is y plus 1 by y, which will again become square root of y minus 1 by square root of y whole square plus 2, which will be greater than 2. Problem 84 says that solve log of x square plus 8 with base 0.3 greater than log of 9x with base 0.3. So since in this case the base is 0.3, that is less than 1, if we take anti-log, the sign of inequality will be reversed. So it will become x square plus 8 less than 9x. So that means x minus 1 into x minus 8 is less than 0, which implies that x will lie between 1 and 8, which are root of the quadratic equation here. Problem 85 says that solve log of 2x minus 3 with base x minus 2 greater than log of 24 minus 6x with base x minus 2. Now, here there can be two cases. The first case is when x minus 2 lies between 0 and 1. That is, x lies between 2 and 3. In this case, sign of inequality will be reversed. That is, it will become 2x minus 3 is less than 24 minus 6x. So that means x is less than 27 by 8. But x is less than 3 from here. So the limiting value of x here would be 3. Because 27 by 8 is greater than 3, so the limiting value will be 3. That is, x will lie between 2 and 3. That is the first case. Now the second case could be that x minus 2 is greater than 1. That is, x is greater than 3. In that case, 2x minus 3 greater than 24 minus 6x. That is, x greater than 27 by 8. So there are two cases here. In one case, x is less than 3. In the second case, x is greater than 27 by 2. However, there are other restrictions. The other restrictions are that 2x minus 3 should be greater than 0 and 24 minus 6x should be greater than 0. And also x minus 2 should be greater than 0. So if you combine these 5 conditions, you will get x as 2 less than x less than 3. Problem 86 says that find the interval in which x will lie if log of x minus 1 with base 0.3 less than log of x minus 1 with base 0.09. So in this case, we can write 0.09 as 0.3 square. So again, you see that the base is less than 1. So the inequality will be reversed. It will become x minus 1 whole square. It has become square because we removed the square from the base of right hand side. So x minus 1 whole square greater than x minus 1. That is, x square minus 3x plus 2 is greater than 0. That means x will be either less than 1 or greater than 2. Now for the logarithm to be defined, x minus 1 should be greater than 0. That is, x should be greater than 1. That means if you combine the case, since x has to be greater than 1, x cannot be less than 1. Now x is greater than 1 and x is greater than 2 as well. That means x will be greater than 2. So this is written like half open interval. This parenthesis means half open. That means it will not include the value of 2. And this is half closed, that is, it will include the value of infinity. If it is a parenthesis, then it is open. If it is a bracket, then it is closed. Bracket means it will include the value, and parenthesis means it will not include the value. Problem 87 says that solve log of x with base half greater than or equal to log of x with base 1 by 3. So in this case, we introduce a base of half on right hand side. So if you see here, log of x with base 1 by 3 can be written as log of x with base log of x by log of 1 by 3. Then you multiply and divide by log of half and log of half. So combine log of half with base x. So it will become log of x with base half. And you combine log of half by log of 3, 1 by 3. So it will become log of half with 1 by 3. Now I bring everything into left hand side. It becomes log of x with base half into 1 minus log of half with base 1 by 3. So this we can write as log 3 to the power minus 1 and 2 to the power minus 1. So it becomes log of 2 with base 3. Now 1 minus log of 2 with base 3 will be definitely greater than 0. So we eliminate that and we write that as log of x with base half greater than 0. That means x will be less than or equal to 1. So since x would be less than or equal to 1, we will have a range. But x has also to be greater than 0 for the log to be defined here. So the range would be open on the side of 0 and closed on the side of 1. So this is half open, half closed interval, which is 0, 1. Problem 88 says that solve log half log of x square minus 5 with base 4 greater than 0. I misread it. Log of x square minus 5 with base 4 and log of that with base half. That's what is given. So we remove log of half and change the sign of inequality. So half to the power 0 is 1, and greater than 0 was there, it will become less than 1. So again, we remove this log 4, we take anti-log, so it becomes x square minus 5 less than 4. That is x square less than 9. That means it will lie between minus 3 and 3. Only then x square will be less than 9. But for logarithm to be defined, x square minus 5 should be greater than 0. And also, log of x square minus 5 with base 4 should be greater than 0. That means there are two conditions, that is x square minus 5 greater than 1 from this. Now this means x is less than minus square root of 6, or x is greater than square root of 6. And from here it would be square root of 5. So now you see we will have two ranges here. That is minus 3 to minus square root of 6 and square root of 6 to 3. Problem 89 says that solve log of x square minus 2x minus 2 less than equal to 0. So we remove the log, we can write x square minus 2x minus 2 is less than equal to 1. So by applying the quadratic equation sign scheme, we get x to be lying between minus 1 and 3. But for log to be defined, x square minus 2x plus 2 should be greater than equal to 0. That is, x should be less than 1 minus square root of 3, or x should be greater than 1 plus square root of 3. So the range is half closed, half open for the interval minus 1 comma 1 minus square root of 3, and half open, half closed for 1 plus square root of 3 comma 3. Problem 90 says that solve log of x minus 1 whole square with base 2 square minus log of 0.5 x minus 1 greater than 5. So we rewrite log of x minus 1 whole square with base 2 square as eventually it becomes 4 into log of x minus 1 with base 2 whole square, and log of 0.5 x minus 1 becomes log of x minus 1 with base 2. So these are all greater than 5. Then you can find from this quadratic equation that this log of x minus 1 with base 2 should be either less than minus 5 by 4 or greater than 1. Now when this is less than minus 5 by 4, x is less than 1 plus 1 by 2 into 4th root of 2. And for logarithm to be defined, x minus 1 should be greater than 0. So x will be between 1 and 1 plus 1 by 2 4th root of 2. Now when x minus 1 is greater than 2, then x is greater than 3. So this is for this case. So now we have this range, that is 1 comma 1 plus 1 by 2 4th root of 2 and 3 comma infinity. So with this we come to the end of 9th set of problems on logarithm, and I hope that you have found this video useful. If so, please subscribe to the channel and like the video so that it can reach more students like you. And as you know, that's how YouTube algorithm works, that when you like the video and subscribe to the channel, YouTube suggestions will include this video more often. So please help your fellow students by subscribing to the channel and liking the video. And if you have a question or a comment or you want to say something, please make use of the comment box. Thanks a lot for watching. Enjoy.